Hi everyone and welcome back. Welcome to the microservices series. And in the last couple of videos, we are exploring deploying microservice as a Lambda, and we are exploring AWS CDK. So here we are going to explore how we can deploy our Nest.js service as a Lambda, and then how we can expose all the different HTTP methods or HTTP verbs from that Lambda. So currently this is a typical API gateway. How it works is, let's say you are using serverless framework or any other technique. What you will do is you will create API gateway, and then you will create all these Lambdas separately, right? So this can be a user Lambda, a profile Lambda, account Lambda, and they should be able to handle individual requests. So maybe it is doing HTTP get users. If you need to create something like post request, then you will be creating another Lambda. That is when you are creating individual APIs as a Lambda. Let's say this is HTTP post users, right? This is what earlier we used to do when we were not having some modern modules. The latest things which has been introduced in the serverless framework. So this is what we used to do, and today also you can do it. So this is the API gateway. I'm logged into my AWS console, and here you can create a new API. You can have any Swagger file. You can just pass this, or let's see if I create a simple API gateway through the example API. Okay, so what it will give you, it will give you all these REST interfaces. Okay, get. So this integration request right now is attached to the mock, not to the Lambda. That's the important point. Let's say if I'm doing this. So this is integration request is currently mapped to the mock request, but it can be attached to Lambda function also, because Lambda can be triggered. So this is what the Lambda, because if you see what is the Lambda, Lambda is nothing but just a function, and Lambda can be triggered from different points. It can be triggered through the API gateway. It can be triggered through the S3. So let's say this is the S3 bucket, and you actually put some item into this, then you can add a trigger that whenever somebody adding a new object, trigger this Lambda. Or this is the Dynamodb stream, that whenever anybody is writing to the Dynamo table, you trigger this Lambda. So Lambda is just nothing but an event driven system. You can say it can be invoked through different event trigger. So if you just see the Lambda trigger model, what all different events through which Lambda can be triggered. There are many ways: synchronous and asynchronous. I will just talk about synchronous. Let's say synchronous means you are just hitting a HTTP interface, talking to the API gateway. API gateway will trigger your Lambda. Or asynchronous event, let's say we have SNS here. I mean, these are all our AWS component, SNS, SQS. Or you can have SQS, simple queuing service, simple messaging, simple queuing service, simple notification service. This is SNS, this is SQS. And whenever any event is published to the SNS topic, a Lambda can be triggered. Whenever you put anything in the SQS queue, then Lambda can be act as a handler. So these all are Lambda triggers which you can use. Here we are using a plain and simple API gateway. So whenever you send a request to the API gateway, we want to trigger the Lambda. So these are all, and stream based also, they like DynamoDB stream, Kinesis stream. Whenever there is a change in the stream, you can trigger a Lambda. Or SNS, SQS, S3, whenever you are putting some object, updating, deleting some object, you can trigger the Lambda. Or whenever you are putting something in SNS or SQS, you can trigger Lambda. So Lambda is really a big thing for the serverless architecture. And here we are executing the Lambda when you hit a request on the API gateway. So this is what I was talking about. This is the mock API, pet store, right? And these are resources, HTTP resources, HTTP get, HTTP post, HTTP get by ID, right? Here you are trying to get a pet by ID. Here you are trying to create a pet. Here you are trying to get all the pets. Here you are trying to get, I think this get is doing nothing, just a return. So currently it is integrated with the mock request, but you can change it. How we can change it? I will just go to the integration request. Currently it is mapped to the mock. This is the mock, but you can change it to the Lambda function. Then here you need to specify the Lambda function which you wanted to connect to, right? All these things. But here, what is the catch here? For each and every request, you might be pointing to a different lambdas. So let's say in this architecture, if we have like, let's say 20 APIs, I will be and ended up writing 20 different lambdas, right? This is pointing to a different lambda. This is pointing to a different lambda. This is pointing to a different lambda. It's not what I want. What the target, our target is, let's say, let's clean this up. Or maybe I will just copy this thing. So what I'm trying to explain here, I'll just try to clean some blocks. So here my point is that that's fine. You can trigger a API call through the API gateway, but here I don't want to have write 10 different lambdas. What I'm going to do is I'm going to proxy all the requests to this particular lambda. This can be your Nest.js CRUD operation, right, for the user. So all the requests I will be proxying from API gateway to this lambda. So that is the advantage of this. This is what I wanted to achieve, because I don't want to write 10 different lambdas for my API gateway. So I will just create a proxy interface. So proxy will take the API gateway, all the requests to the single lambda, and I will be deploying this service as a single lambda. I mean, this is possible with the tools and some modules, serverless application model, which was introduced recently, and due to that we can deploy a simple express TypeScript app having 20 different APIs, or Nest.js microservice having 20 different APIs as a single lambda. So you proxy all the requests to this lambda, and this lambda has internal routing. It already knows that when the request is coming API v1 user, I need to trigger I need to call this function when the request is coming for API v1 auth. There will be a code which it will be executing, but for that it's not like a single lambda. The whole microservice will be bootstrapped every time whenever there is a request coming. But we are fine because this is a lambda. It's going to sleep after when we are not using. So we are going to proxy all the requests, and this single lambda is playing with all these things. This is like a Nest.js lambda we are going to create and deploy as a single lambda, and we are going to create a proxy interface. So all the requests will proxy, because you are going to hit the API gateway endpoint, and it is going to proxy all the requests which are coming after / to this API, this lambda, single lambda, and single lambda has internal routing, which should be able to handle the requests coming for that. So this is what we are going to achieve. Here I was just explaining, okay, this is simple API gateway, and I think it has created the APIs also. I can just deploy that. We can create a stage also, let's say dev and prod deployment, because currently it's just a mock interface. This is mock interface. I can deploy this API and new stage, let's say dev. I will deploy and I will delete this resource. I don't want to be charged by AWS. So when you copy this, what it will give you, welcome to pet store, your API is deployed. on AWS environment, right? And it is giving you, I think, all these endpoints. What are the endpoints? If you see this, there is a pets is the endpoint, right? It is giving you this JSON. So my API gateway is live with the mock API integration, right? So the same thing we are going to do here. It will be just having one proxy request that will directly go to the Lambda, and Lambda will take care of. We are not going to see all these things because we are going to have a single proxy interface that will talk to a single integration Lambda. Okay, I need to delete this resource. That's it. So let's take a look on to first on AWS CDK remaining part, because this is what we want to achieve. But to achieve this, first we need to understand more on AWS CDK. So we are going to take a look on more examples, let's say with the DynamoDB, API gateway and Lambda function. Then we will come here and we will try to deploy our Nest.js simple microservice as a Lambda. Everyone, and welcome back. In this video, let's take a look on other constructs also, like having DynamoDB, Lambda, S3 buckets and all together. Okay, so you can create a simple DynamoDB construct, something like this. Just a simple DynamoDB.table, and the table name, let's say we are using users table, users, and you can also specify the stage in which you are creating it. And table name is simply API users, and then it's a DynamoDB table, so you have to specify what is your partition key, what is your sort key, and all those options you can specify in this. Let's say the sort key is created at sort key, the name is created at, which is of type number, DynamoDB.attribute type.number. Okay, so this is just like a simple table definitions you have created. It's like a DynamoDB. Similarly, you can also create a simple S3 bucket. How we do it? Const user uploads or user artifacts, whatever, new CDK dot, there are many ways to do it, so you can just do AWS S3 dot bucket, or you can import it like this. Import same as the DynamoDB S3, and here it will be AWS it's not completing. It says CDK dot AWS S3. Is it something we have here? It's still thinking. Typescript is a little slow here. So S3 bucket, and here what we can do is we can just pass this bucket name, let's say user docs, and stage, this is the environment, and then whatever the properties you want to pass for the bucket name is, let's say the bucket name is simply what bucket name you wanted to put, user docs, and then stage, and then retention policy, removal policy is CDK dot destroy removal policy dot retain. Like if you are just doing a CDK destroy, then do you want to retain it or you just wanted to destroy it, like get rid of these resources? So here we are creating this S3 bucket, user upload S3 bucket, and here is, you can say user Dynamo table. Okay, so we have these two resources created. Now how can let's create a simple Lambda function, and then we will give permission to this Lambda function to read and write to the Dynamo or to read and write to the S3 bucket. So const API Lambda function, and here also we will use CDK dot Lambda CDK dot AWS Lambda. So you can access the resources like this also from CDK dot function, and here you need to specify the whole different properties. This your function name, okay, API user stage, this is my function name, and rest all the properties which we can specify. And in the properties it's all about function name. There are many properties. Runtime will be what is CDK dot AWS Lambda. Again we need to just look for the whole path. AWS Lambda dot runtime dot node 16, memory size 1024, description. What are the other properties? Memory size, log retention is like how long you wanted to retain the log for this. So we will use this everywhere. CDK dot lambda dot, here is retention days. Do we have something properties like this? CDK dot AWS, it should be AWS logs dot retention days, and you can specify, okay, how many days? 5 days. Okay, so you just need to take the help from TypeScript to play around with all these things. And these are the environments we have, and we need to specify the handler. Handler name is, let's say, API Lambda handler. This is your function name, and then the code CDK dot AWS Lambda dot code dot assets from assets, and here you need to specify the path. I will just specify path dot join from correct dir name. Just go one step back, and then there is maybe a source directory. From there you can get the index.js. I think we already have something, index.js. We are not writing TypeScript because it requires bundling and a lot of other things. So this is simple code. Environment is, you can pass the bucket name, dynamo tables and all. Current directory name, I think we don't need this thing. We will see. So this is API user. What we will do is, now we have created this Lambda function. So API Lambda function dot grant right. Okay, or let's say this is the S3 bucket we have.
I didn't cap.
User dynamo table dot grant read access read write data to the API Lambda function. And similarly we have user upload S3 bucket dot grant public access or read write to the API Lambda function. This is how you will specify you will give permission to this Lambda functions to read and write. And other than that, you can also add a policies, initial policies. So here we can just specify initial policy, and this policy, these are the policy statements you can add. This will be an array. Here you can add a resources like new CDK dot AWS IAM. These are the IAM policies you are going to add to this Lambda, like adding a policy statements. And what policy statement contains, okay, what effect, there are 3 instructions, right? Effect, actions and resources. So CDK dot AWS IAM dot effects allow Okay, we are doing allow for this particular actions and actions on S3. And the other thing is resources. I mean, either you can specify the ARN of S3 bucket, because on this S3 bucket, I'm just writing a policy that you can do all the actions. So here you can specify, you have to specify the bucket ARN. Okay, so this is like you have added a policy statement with this Lambda. This Lambda can do the read, write and all the operations on this S3 bucket. Why it is complaining? Bucket ARN. Okay, it should be an array. And similarly, you can attach multiple policies. Here, let's say I'm talking about SNS. You can send this Lambda functions can send message to all the SNS queues which are there in this account. So if we don't know the topic, we don't know the ARN, then we can just specify wildcard. That means it can send to all the SNS resources. And then Dynamodb. And we already have a dynamo table resource, user dynamo table.arn. Let's say dynamo table dot table arn. So we will see if this works. I mean, we need to specify the table arn for this. And I think, yeah, we will see. But because we also need to specify the index, all the access to the table resources. So this is how we can initialize the policies. Like this Lambda can do this, do that, and then explicit permissions also added here to read and write to the S3 bucket and read and write to the Dynamo table. And then you can also console output all the resources you are creating using CloudFormation output. So new cdk.cnf output, cloud function output. Okay, so what we are saying is this, and I'm just calling it as a, what is my API Lambda handler, API Lambda function. This is my resource, and I wanted to just set these output export variable names for the stack. So I can, when I want to refer, I can refer it from here, API Lambda function ARN, and the value is the ARN of the Lambda function. API Lambda function dot function ARN. So these are the export variables added to this particular stack. Similarly, we have a couple of more for the Dynamo for the S3 bucket. So this is user Dynamo table. I mean, these should be appropriate names. I'm just putting some random names for now. This should be table ARN, and then there is an S3 bucket. Dot it should be bucket ARN. So these export names will be added, and we can also see that in the console that these are the resources has been created with these ARNs. So let's play with this. On to this source, we have index.js already, and that has a handler, index.handler. We may need to change our stuff in the Lambda. So handler is index.handler. Okay, so that should be good. And in the environment, you can populate, okay, S3 bucket name, DynamoDB table and all, whatever the environment variable you wanted to specify. Let's say I'm just specifying stage, and then I will just deploy this using CDK deploy. Now let's deploy this particular stack, which contains S3 bucket, DynamoDB table, and the simple Lambda function. So we will just do npm run CDK deploy, and we will see what all resources are getting created for this stack. API Lambda stack. Okay, creating the assets, and now if you see what all permission it is asking for, it is creating this particular role, and it is creating all these are the policies. Okay, resource, effect, actions, and principle, and then all the resources, like it is we are giving permissions for the S3, DynamoDB table, and SNS, and it is creating these resources. And we can also see what all resources are getting created in the cloud formation. So it is creating cloud formation chain set and going to create all these resources for us. I mean, there may be a failure also if the resource already exists and you are trying to create it again, or you are creating some stack name which already exists or resource already exists. In that case, you may see a problem. You can see a DynamoDB table with identifier already exists. So it will roll back. It will not create anything. Can I add a policy here? Removal policy is cdk dot removal policy dot destroy, and here also I will just say destroy. So when I just do npm run CDK destroy, it should clean up both the resources like S3 bucket and the DynamoDB table. I mean, ideally we should not destroy them, because let's say somehow if you destroy a stack, your persistent like S3 bucket, RDS, DynamoDB table should also gets destroyed. So we should avoid it. Here I'm just creating a demo and I'm just showing, because when I do this again, I'm getting this error because maybe a partially this stack was deployed and those resources were created and the stack was not completed. Now when I'm trying to create the stack, it is saying duplicate. So first let's clean up this stack by removing this S3 bucket and removing the table. Now I will just do is CDK deploy again. So it should create the resources again. So we are just doing simple plug and play with the AWS CDK and seeing how these resources are created, destroyed, what is the retention policy. So ideally now this should work. We should be able to see all the stack created with all these three constructs, which is DynamoDB table, S3 bucket, and a simple Lambda function. So it is creating cloud formation chain set. Now what is this? API docs development already exists, because this S3 bucket already exists and we cannot create it again. So what I will do is I will just change this name. Ideally it should clean up the resources. Once we create these resources, we will do CDK destroy command to see if both these resources gets destroyed or not. You can see here I just now change the resource names. So what it will do, it will automatically replace those resources with this. So that's also another way to clean up the resources. If you change the name, then the old resources, because now the stack definition has been changed. Now you are using a different S3 bucket with a different name. So the old S3 bucket, because the removal policy is destroy, will be destroyed. And similarly for the DynamoDB table. So it is creating this DynamoDB table, S3 bucket, and the roles, and creating this Lambda stack. And it will take some time because it is creating CloudFormation template and just then deploying the CloudFormation templates to the AWS. So here you can see the outputs. So you can see there is a S3 bucket, there is a S3 bucket, Dynamo table, and the Lambda function. And we can go to DynamoDB, Lambda, and S3 bucket to see all these things. So I can see one table there. I can see S3 bucket, and this is my Lambda function. Okay, you can see the sort key and the partition key, user ID and the created at, and this is my Lambda function. I'm still using simple JavaScript because for TypeScript I need to do the bundle and all these things will happen. This is my S3 bucket. Now what I will do is I will try to clean up the resources. Let's say if this removal policy really works, destroy. So what it should do is it should clean up the resources, means the DynamoDB table, Lambda, and this S3 bucket should be gone once we destroy this stack. So you can also see the progress in the CloudFormation, like whatever is we are doing through the CDK should be reflecting the same here. So delete is in the progress, and what all events you can see it is deleting the resources also, so that's good. So it's deleting this S3 bucket. Delete complete. The only thing is the Dynamo table. The delete complete. So now if I just go and check the S3 bucket, I should not see that S3 bucket now. You can see that bucket is gone. User 1 docs app development. The Dynamo table is also gone. Okay. So that's a clean way of doing things, and to avoid any duplicates, because earlier we were facing some errors because the S3 bucket was already there. Maybe I did a Control-C while creating the resources, so the resources were partially complete, and then when I'm trying to do CDK deploy, the same name resources are already existing, because once you do the CDK deploy, you can do CDK deploy 10 times. It won't complain that resource already exists, because that is part of the stack, and it won't create that resource again until unless you update the resource name or simple stack with S3 bucket, with a simple DynamoDB table and a simple Lambda function. Now we will introduce API gateway here, which is AWS API gateway. And we will see how it really works. So what we are doing is a Lambda cannot be triggered directly without API gateway. Okay, so this is our Lambda. There can be multiple Lambda functions. Okay, and for data storage we have a Dynamo table. This is like we are talking about serverless stack. DynamoDB, and maybe we also have S3 bucket to store some content from some services. Okay, so how it really works is the request will come from the client that has to go through the API gateway. Now API gateway is like a simple construct we need to create. This API gateway can do couple of things. I mean, this is AWS API gateway, can do n number of things, but here we are talking about particular use cases. Either you can create a simple proxy so that whatever the request is coming from this API gateway, API v1 user, API v1 anything, will go to this Lambda. And we already know that in the current stack what proxy will do is all the requests will directly go to the Lambda, and then Lambda can just do its stuff like writing to S3 bucket, reading from S3 bucket, or writing to the Dynamodb table. It's like a simple REST API. Right, these are the simple REST APIs we are exposing. Or what you can do is you can go in the old way. We are not creating a proxy. Here on the REST API gateway, what you will do, you will create a resources. Okay, the user, you will create a resources like user is a resource, and then you will create a methods like get, put, post. I will show you how it really works manually, and then we can also think about doing it. So this is, let's say, API gateway. We'll go to that console, API gateway. Here, if you create a API gateway manually, okay, HTTP APIs, demo APIs. So here you can add a methods like for the integration request. This is the default name is the stage. That's fine. Create. So we are creating API gateway. Now on this API gateway, what you can do is you can create routes, resources, and all. I mean, this UI has little bit changed since I saw the last. So here, this is the get request, and this is the resource. You can specify here users. What you are doing is you are adding a get method to the user's resource. So you can see this is the get method. Now what you can do is you can attach a Lambda to it. So integration, I think it will be in the inside integration. Create and attach an integration to this. You can choose a Lambda function. Okay, now you might already have some Lambda function like this Lambda edge function, or currently we don't have any other Lambda function. And description, this UI had changed a little bit recently on the AWS API gateway, but this is how you are defining the mapping. Similarly, here if you go to the routes, this is the get function, but you can also create another function like, let's say, the post on the users. So what you are doing is you're not creating a new resource, you are just creating a new method. Similarly, let's say I'm just creating a put method on the users. So users is actually a resource, and these are the methods you are creating. So you can actually go manually and attach the integrations. Okay, for put, I have another Lambda. For get, I have another Lambda. For post, I have another Lambda. That's just a way in which we do create API gateways. Okay, I will just delete this one. We'll create our API gateway, or we just create a proxy, because in our case, what do we have? We have this, actually this is actually a user microservice or auth microservice, because every service will have its own API gateway and the Lambda. So we just need to create a proxy. So whatever the request is coming, this API gateway will proxy to the Lambda, because Lambda cannot expose itself to the outside world. You need to attach an API gateway, and the API gateway we are going to have is just going to proxy, because this Lambda is not just a simple one single file, it's a whole Nest.js microservice, which already has all the APIs in it. It's like a simple living HTTP server, which has already all the APIs, get, put, post, and all the resources. So the API gateway will just do the proxy, and this Lambda will handle how to deal with all the requests coming for different resources and different methods. That's just a one way. Another way is you define all the methods and all the resources at the API gateway, and link individual small lambdas which are not coming with API gateway, each and every one. Let's say this is for HTTP get, this is for HTTP put, this is for HTTP post. So here we will be doing the request mapping with the different methods. That is just another way. So how we can achieve all those things? If you want to just create a simple proxy, what you will do is, I will just create a gateway, const API gateway equal to, and now here we will be just using the CDK construct, cdk.aws gateway AWS API gateway dot lambda integration, and here you will pass the scope and your API gateway name. So the API gateway name can be simple as user API gateway, and you can also pass the stage. And then the next argument is, because here this is the proxy API gateway, so you have to pass all the arguments like what is the handler, what happened, lambda rest API, it should be lambda rest API. Okay, now we can pass all the arguments. Handler is your lambda function which you created here, API lambda function, and deploy through all the required arguments. Proxy, this is important because we are doing proxying, and then the MIME types for the API gateway, because API gateway is just going to proxy all the requests. So what we will say is whatever is coming except all the MIME types. And another option is the deploy options. We also want to pass the stage name. We already have a stage, so this will create just a proxy, and then we can just put it in the export names. This is user API gateway ARN. So here we are creating the API gateway. We can just print the API gateway bucket, API gateway REST API name. API gateway dot REST API name. Okay, and we just do is CDK deploy. I think stage is already populated. So here we just have created a proxy API gateway that will just take all the requests and take it to this lambda. Now this lambda function is doing nothing but just a simple, if you see the lambda function, it is just sending this simple message, but it can be a simple Nest.js service. And maybe I have already destroyed this stack, so I will be creating everything again. So it will be creating all the resources. That's a little bit time taking. Now next thing we are going to talk about is how we can do the mapping of individual resources with the different lambdas. Okay, it's not like we create a simple lambda. There can be multiple lambdas and they will be attached to the different HTTP methods and the resources at the API gateway level. So here we can see that we created this API gateway, and this is just doing only proxy, and you can see the integration. This proxy request is going to the lambda function, this lambda function. So this is what we created in the last video, and it is only talking about how we do the integrations. Okay, there can be a proxy integration with the API gateway, or you create these individual HTTP resources and build a REST APIs, like you build the resources on the API gateway, which we talked about, like here you can just create a simple API gateway and then create the resources manually, that we have seen in the last video. Now what we are going to do, that we are going to automate it. We are going to create a simple REST APIs through the code. So I'm just going to take some helper example and try to create a simple REST API interface. Okay, so this is our simple stack. Okay, that is using Dynamodb, simple lambda function, and this API gateway. Now we are not creating a proxy API gateway. What we are creating is, we just want to create a simple REST interface exposed through the API gateway itself, not through the Lambda. So the Lambda is just like simple functions. So I will try to just change it, Lambda integration. So this will come from the AWS, sorry, CDK dot, it will come from CDK dot AWS Lambda, or it's come from AWS API gateway dot Lambda integration, and here we need to pass the Lambda function, API Lambda function. Let's say this is API users, API get user Lambda function. Okay, and we will just add the integration, and this we need to attach it to our resources. So the resources will be, here we are creating a proxy resources items, and we can call it as like a user resource, and we are adding a one method get to this get all integration, get all user integration. Just use some proper names so we will know. And there is a method post, and there can be another function we can create. I will just copy it for now. This is pointing to the same function. Here it is API get user, API post user. We need to change couple of things. API maybe a get user, just do some changes. API post user, and also you need to change the Lambda function, otherwise you get a conflict, right? API get user Lambda, API post user Lambda. So we will just create it as a API post user Lambda, or better names is create user, update user, get user. So we will just add some permissions also, because we are using Dynamo and S3, so we can add permissions to this another Lambda also. And then we will inspect the whole AWS resources, whatever we are creating. This REST API should be coming from API gateway, AWS gateway, dot REST API. So here, what is your users API name? It's like users APIs, and I can just put a stage here. This is my stage name. Okay, and this is like resource I'm adding users. So it will be HTTP users get, HTTP users post, and then there is another integration we need to create for the second Lambda, which is post users integration. And here you just need to pass API post user Lambda function, and then add this Lambda integration to the function. And now we can also add cross origin resource sharing policies that we can skip for now, because sometimes when you do the integration with the front end, you need to send particular headers. You need to allow front end which is running on different endpoint or different port to communicate to the API gateway. So you need to send a cross origin resource sharing headers from this Lambda so that they can talk. Now this is first Lambda, API first Lambda ARN. This is, we are just exporting them as an output. API post user Lambda ARN and function ARN. Okay, now what we did is, we have created this, we are creating this users resource on the API gateway. And where we are creating API gateway, here it will create an API gateway for all these resources you are creating. Here you can create n number of resources. I mean, I really don't do the in this particular times, we just use a Lambda function having all the microservices in it. But if you want to do the mapping, when I say mapping, means we are actually creating these resources here. Okay, I'm using users auth cart, all these APIs, and then for each and every get, put, post method there will be individual lambda pointing to this. So users, this is simply you can say simply HTTP get. Right. So now another API is, let's say, the create user. It will be HTTP post. Resource name is still / users. This is resource name. And similarly, there will be another lambda integration you will do. You will write lambda. So you can see the same thing we are doing in the code. We created a lambda, then we are creating a resource, and that resource, on that resource we are adding the methods, HTTP methods, get, put, post, delete, patch, and adding those lambdas to those particular methods. Because when I say HTTP get users, that particular lambda will hit. When I say HTTP post users, there will be another lambda which will be submitted. So this is REST API name is user service stage. Okay, now let's try to deploy it. We have REST API API.REST API name. I mean, we may see, because I didn't destroy this earlier stack, so because we changed a lot of names, the resource names, either because export names may also create a conflict. I will just create okay, so everything is same, stack name is same. Okay, let's see, do we need S3 bucket? So you can say user API is upload, and for Dynamo table API users table, let's say, okay, API get, these are the two lambda functions. And now what we need to do is simply CDK deploy. So what CDK deploy will see is we have two lambda functions, and these two lambda functions are simple, pointing to the same resource, and then two lambda functions. Resources exists, and I change the and this is simple lambda function. This is API gateway, this is S3 bucket, Dynamo table, API get function, API post user function. Now let's see this on the console. So here we can see two lambdas, post user, get user, and on the API gateway I can see this API gateways. So the earlier API gateway might have been deleted because we replaced it. So this is now our API gateway, and you can see the resources. You can see the resources, get, and this is the integration request is going to the lambda function, this lambda function. Post is also going to the same lambda function, right? You can see the integration is happening through the lambda function, right? We have just a simple stage prod. So the API endpoints looks like this. You can see hello from my lambda function. This is get request. So this is coming from our API gateway response, right? Okay, we don't have anything else, like we didn't create any API gateway models. It's just like simple resources we have created, and those resources are just hitting the lambda, and that all happening through the AWS CDK. Apart from that, we also, let's check on the lambda functions and their permissions, because we were attaching some policies to the lambda function so that we can see configurations. Okay, you can see CloudWatch logs, it has an access to S3, SNS, and Dynamodb, because we attach the policy, and you can see the role document we allowed for S3, read and write, anything, all the operations on this particular bucket. And for the SNS, for the DynamoDB, all the operations, right? And rest all are like creating the logs and all. Here you can individually see what you can do on the DynamoDB. These all operations you can perform on this particular table, on the S3 bucket, on SNS. I mean, you can access or any SNS topic, you can send it a message, and this is the CloudWatch logs because we added this policy. And you can also monitor and check the logs, what is happening with this particular Lambda. So we are sending a request. So when we send a request, it will generate the logs, and that it will generate the log stream, and that we can see. Okay, I'm not printing anything in the logs right now. I can just see if the logs are getting generated. Currently there is no much logs. So these are the role groups. Okay, so these are the logs created for the API post and API get. And the retention period is, you can see, 5 days. After 5 days, these logs will be gone. So it's a simple stack we have created through the AWS CDK. Now, the another important part is how we are managing the roles and permissions. Here we are doing a grant so that this Lambda, currently this Lambda is doing nothing. It's just like index.js. But when you write a microservice, whole zip file, you should be able to upload using this stack. Like instead of assets, simple file, you can upload a whole zip, and there will be a simple handler, a single function handler that will be bootstrapping your Express service or the Nest.js whole API system. Okay, so this is all about the API gateway. Now we will come to some of other topics of AWS CDK, and then we will jump back to the Uber Eats clone app. So let's see some simple examples. Let's say if I do CDK deploy, what will happen is I didn't change anything in the whole stack, so the deployment will be very fast. I didn't change any resource names. I'm not deleting anything. So it will just check, okay, it will just upload this code. Now you might just do some code update and just deploy. It will be ultra fast because it will generate the CloudFormation template, and it will try to identify what is the change set. And if there is no particular change set, then the deployment is fast and it will give you all the resources. But let's say you are creating another Lambda, which is, I'm just naming it to API put users. So it's like a new Lambda we are creating, and I attached this resource to, this is API put, I guess. Yes. So I added a permissions and created an integration. Put user integration, and this is pointing to this Lambda. So I created a new Lambda, and I will be adding that to this resource users put. So now it's really changed, right? So my Lambda function is API put user Lambda function. And I can just do a deploy, CDK deploy again. Now it can see, okay, there is a new Lambda you have added. So it will try to deploy this, because when it will try to find the change set, it will know, okay, here you can track everything, API Lambda stack, all the resources. You can see generating, adding in the CloudFormation output, get user, post user, and now we will also see put user. It's like it's updating and creating the new resource. This is updating the existing stack and then creating this new resource. So create in progress means we are creating API put user develop. This is the new Lambda function it is creating. So this is all about the stack. Now let's see a couple of more demo, because this is a really interesting topic. We are doing everything